Here I have an actual research paper. I wanted to show you this. This is an actual research paper about using this medicine called Remdesivir for COVID patients. Okay, this is okay. Let me take you to that research paper. Okay, so this paper was published in 2020, October 8th. This is Remdesivir for treatment of COVID-19. The final report, bunch of scientists who have put all of this data. Okay, so again, it talks about a lot of stuff that they've done. Again, I learned a lot about medical research by reading COVID-19 vaccination data, treatments data, etc. So in this, again, I'll walk you through this. I want to walk you through this whole thing so that you understand how to read it. The most important part is this diagram that I wanted to show you. Okay, so if you see this research paper, they're not using hypothesis testing anymore. Okay, so let me walk you through some of the key concepts here. Okay, so they do not use hypothesis tests. All modern medical research, because it is mission critical and you don't want to make mistakes, use something called as confidence intervals. Again, what you see here are all confidence intervals. Okay, this is actual publication about Remdesivir, which is one of the most popular drugs given nowadays for anyone who has COVID, right? Okay, cool. So let's look at that data. It's actually very, very informative, right? So okay. I'll briefly give you an idea, and then we'll understand how this has to be done by us if we were to do it. So this test was conducted on 1,062 patients. Okay, the total sample of patients that were randomized was 1,062. 541 people were assigned to Remdesivir, which means these people were administered Remdesivir. 521 were administered something called as a placebo. What is a placebo? Placebo means they'll give you an injection, but the injection is a blank. Okay, there is no medicine in it. That's how you can compare, right? Because people sometimes might recover because they think they got a medicine. Okay, so 541 people were assigned Remdesivir, 521 to placebo. Now, okay, so let me just zoom this in a little. I want to read this and then dive deep into how to do the statistics part. Okay, cool. So, okay. So those who received Remdesivir had a median, again, look at this, they're using median recovery time. Okay, so let me keep writing this. So there are 1,000, let's write down this data, right? So there are 1,062 patients, some of whom were given Remdesivir, some of whom were given placebo. So roughly 541, okay? So 541 were given Remdesivir, 521 are given placebo, which means no medicine. Okay, so now comes the fun part. Those who received Remdesivir had a median recovery of 10 days. Again, they're not just telling you what is the median recovery, they're also telling you what is the 95% confidence interval on this. Now you might say, boss, what is confidence interval? Suppose you have any random variable. Okay, so let's take the random variable x Remdesivir. This is a random variable and there are multiple observations. Let's say xr1, xr2, so on and so forth, xrn. Okay, so how many we have? 541, right? So let me write down that 541 value here. So there are 541 patients who were given Remdesivir. Now this patient, let's assume, recovered in 6 days. This patient recovered in 7 days. This patient recovered in 9 days, so on and so forth. Some patients obviously would have died also. When patients die, their recovery, the number of days for recovery is often written as infinity because unfortunately they did not recover. Okay, so there'll be all these patients in the data. Now they said the median recovery. Now first question that you should ask is, why are they using median? Why not mean? Because some people are dying, boss. There are some people here who unfortunately are dying, which means the largest value is infinity. What do you do by averaging these values with infinity? Okay, that's why they're using median. That's very important. So the median recovery time is 10 days. So when you take all these observations, the median of these, the median XR is 10 days. But we also want not just, again, this is called as a point estimate because you're giving me one number here, one point of data. What we want also is, we want to say, hey, in what range of values will 95% of these observed values lie? I want to say, hey, let's look at this again back here, right? So they say 9 to 11. So they are saying that 95% of these patients, okay, so look at, so the 95% confidence interval they're giving is 9 to 11, which means the median recovery time, if you think of this as a random variable, look at this. If you think of the median recovery time is 10 days, but the median itself, we know with a 95% chance. Okay, let me erase this. I think that has to be told very, very carefully. So remember, okay, so let me go one step here. So the median recovery time for those who are given remdesivir is 10 days. But this median itself is a random variable. It has its own distribution. And we think that this median will lie between 9 to 11, and we are 95% certain about it. Which means if I repeat this experiment on bunch of patients, most likely with a 95% probability, this median value will lie between 9 to 11, which means it's quite close to 10. Again, this is a 95% confidence interval of the median of those patients who are given remdesivir. That is very important. That's why you have to read it very carefully. Okay. So those who received remdesivir has a median recovery time of 10 days, 95% confidence interval of 9 to 11, as compared with 15 days. Look at it. Those who have placebo. Okay. So let's write down, right? So where is this? Okay. So for these people, the median recovery is 9 to 11 days. This is the 95% confidence interval, and the median they observed is 10 days. On the other hand, for those who have been given placebo, their values, the median value itself is 15, and their confidence interval is 13 to 18. Again, here we have two observations. We have a point estimate. This is just one point. This is a 95% confidence interval of the median, which means if I have to repeat this experiment again and again and again, 95% of the times the median will lie in this range. If I repeat this experiment many, many times, with a 95% chance that the median will lie in this. Again, this is called an interval estimate. This is what is called as a point estimate. We will see why interval estimates are more powerful. We will actually go through this, understand the results, and ask ourselves, how do I get these in the real world setting if I don't get anything? Okay.